So now we are going to look at the shape of our atomic orbitals. Tadi you already know how to describe the address of your electrons, okay, by N, L, M, S, okay. So satu elektron akan ada one unique NLMS, one unique address, alright, within your atom. So now we want to know the shape of our orbital, tempat awak letak elektron tu. So dalam awak punya orbital ada elektron. Okay, ada elektron. So as orbital, as I have said before, it is spherically symmetrical. So kalau dia minta shape of your S orbital, you can just call it spherical shape lah. Okay. So spherically symmetrical shape with the nucleus at the center. You have the nucleus at the center. Okay, and then there is sphere. The probability of finding electron at the distance from nucleus is the same from all directions because dia adalah bulat saja. Okay, so the probability to find it anywhere around your nucleus will be the same because it's only bulat. So you will get an s orbital when L is equals to 0. Okay, so L equals to 0, M is equals to 0. So bila L is equals to 0, awak ada s orbital, awak punya M will equal to 0 because awak punya s orbital only has one orientation like I said before. Okay, awak kedudukan s orbital tu ada satu saja. So the larger the value of n, the larger the size of s orbital. So n, you know that it is your shell, your principal quantum number. So let's say here we have 1s, the size is this. So when you have 2s, okay, orbital, it is bigger, tapi shape dia sama je, spherical juga. When you have 3s, it is much more larger, okay, because awak tambah awak punya shell kan, tapi awak punya S ni sama kan? Maksudnya L awak semua equals to 0 lah. Okay. Tapi ini N equals to 1, N equals to 2, N equals to 3. Okay. So, that is S orbital. Next we have P orbital. So, P orbital, it represents the dumbbell shape. Okay. If you lift, if you work out, you know what is a dumbbell. Okay. Kalau tak work out pun tahulah dumbbell tu apa. Okay. Shape dia macam mana. So you have p orbital when L is equals to 1 and p orbital will have 3 values of M, maksudnya it will have 3 different orientations which are px, py and pz. Okay, this means one p subshell consists of 3 p orbitals. So maksudnya if you have 2p orbital, 2p subshell, 2p orbital, okay, subshell or orbital, you will have 3p orbitals within that subshell. So maksudnya dalam 2p ni, okay, dalam dia ada apa? Ada 3 orientation, 2px, 2py, 2pz. Maksudnya 3 orientation berbeza. Okay, so ini ada orbital, orbital, orbital. Ada 3 orbital within 2p. So sometimes you will write it as sini 1, 2, 3 and awak tulis 2p je. Tak payah tulis 2px, 2py, 2pz. So this is understood that within the 2p subshell you have 3 orbitals. Okay, 3 orientations of your 2p orbitals. Okay, so so these 3 p orbitals tadi, px, py and pz, each with the same size, shape and energy. Maksudnya dia punya size, shape and energy adalah sama. They only differ from one another only in orientation. Okay, dia duduk dekat axis mana berlainan. Itu je yang berlainan. Yang lain size, shape and energy sama. Energy yang sama maksudnya orbitals tu adalah degenerate orbitals, same energy. So this is the shape of your p orbitals, okay, like I drew just now. So make sure when you draw your p orbitals, okay, awak punya axis tu sama je, x, y, z. Okay, make sure it is uniform, x, y, z. Okay, x, y, z. Okay, so make sure label and draw nicely lah. Okay. So the p orbitals with larger n values, maksudnya shell of their principal quantum number are larger than a 2p orbital. So maksudnya awak punya 2p orbital is smaller than 3p orbital lah. Apa yang lebih besar daripada 3p orbital? It will be 4p orbital. Okay. Lebih tinggi awak punya n, lebih besar awak punya n, lebih besar lah awak punya p orbital tu. So next we have d orbitals. Okay, so d orbitals, they do not all look alike. They look different. Okay, so you will have d orbitals when L is equals to 2. So when L is equals to 2, you will have 5 values of M. That means you have 5 orientations of d orbitals. Okay, these orbitals punya nama will be dxy, dyz, dxz, dyz, dx square, y square, and dz square. So these three, they are orbitals that lie between the axis. Between the axis meaning, okay, when you have d xy, okay, awak lukis awak punya axis x, y, and z. Okay, so dxy means your lobes, it lies between the axis x and y. So this is x and this is y. So you are going to draw it like this, between the axis. Okay, so maksudnya awak ignore lah z axis tu, last baru awak lukis z axis, macam tu. Okay, so it lies between. So kalau d x z pula, awak lukis x and z. Okay, it lies between. Dia tak sentuh the x and z axis. Okay, tapi dia sentuh y axis. If you look here, okay, dia tunjuk the plane xz plane. Okay, dia duduk between the axis. Okay, it sits on the xz plane, but between the xz axis. Okay, same goes with dyz. Okay, awak lukis y and x, and then you just draw the loops between the axis. Okay, and then baru letak x. Alright. The other two, they do not lie between the axis, your loops, but they lie along the axis. So bila awak ada square ni, okay, ingat, it means that your loops lie along the axis. Maksudnya atas axis tu. So dx square y square senang je. Okay, awak lukis x, y, z. Okay, and then your loop will sit on the x axis and y axis. Okay, macam tu. Okay, so maksudnya dia tak sentuh z axis lah. So dia duduk on x and y axis. Dz square pula, kita panggil dia ada donut. Okay, dia ada donut. So dia akan duduk on the z axis. So you have to draw macam ni, and then it has a ring around the lobe, this donut. Okay, so that is dz square. Okay, bila awak lukis dz square, you still have to show your x, y and z exist. I mean x and y exist tau. Even though dia duduk dekat z axis saja, you have to show juga. So this is the summary to determine an orbital. So I think ini awak boleh baca sendiri. Okay. So this table here is a table that I want you guys to try and complete. Okay. So kita akan start daripada sini. Principal quantum number. If you have n is equal to 1, that means you have one shell only. Then your L will equal to 0 only, because the maximum value for L will be n minus 1. So in this case, when your n is 1, 1 minus 1 is 0. So you only have L equals to 0 lah. So the subshell designation will be 1s, because 1, and when L is equals to 0, you have s orbital. And then the magnetic quantum number, m will depend on L. So when L is equals to 0, then your m will only equal to 0. Okay. And then your electron spin quantum number, your s can be plus half or minus half. So you can write it like this, but I actually prefer you to write it separately, plus half or minus half. So you have two possible spins. Okay. So the number of orbitals in the subshell, you will refer to mana? You will refer to the values of m that is present. So you have one value, that means you have one subshell. Okay. So the maximum number of electrons in shell n will be 2. 2, because S shell 1s, okay, can occupy up to 2 electrons. Okay. So next, when n is equals to 2, okay, the maximum value for L will be n minus 1. So 2 minus 1 will be 1. So maksudnya awak ada 0 dengan 1 saja. So ini 2s, ini, this will be 2. When L equals to 0, it is p orbital. So this will be 2p. Okay. So yang ni isilah sendiri. Okay. So yang ni awak punya magnetic quantum number, the possible values for 2p. Okay. When L is equals to 1, you will have 3 values of m. Minus 1, 0, plus 1. Ni 1 kan? So macam tu je, minus 1, 0, plus 1. Okay. And then ini plus half or minus half. And then this one you will refer to here. You have 3 values. So maksudnya 3 subshells. So 1 subshell will occupy 2 electrons. So maksudnya awak akan ada 2 electron here. And ni 3 subshell will occupy 3 times 2, 6 electrons. So 2 plus 6, you will get 8 electrons. Okay, maximum number of electrons in your second shell will be 8. So do the rest. Okay, I will show you for this one. Saya nak tunjuk yang ni, 0, 1, 2. For this one here, okay, your subshell designation will be 3. D, okay. When L equals to 2, you have d orbital. And then your magnetic quantum number will be, since this is 2, maksudnya it will be minus 2. You can have minus 2, minus 1, 0, plus 1, plus 2. Sorry, plus 1, plus 2. Okay, so ini awak tahu. So if we have 5 orientations here, that means we have 5 orbitals in one subshell. Okay. So the maximum number ni awak kira lah. Okay, so do the rest. Okay, try to do the rest. And we will check this during class. So, example 2. This is quite a foundational question. Okay, to your understanding. Predict the following quantum numbers. Maksudnya NLMS. Awak punya address ni, whether they are allowed or not. Okay, so let's check the first one. Okay, when n is equals to 1, your L can equal to 0. Betul tak? So bila n equals to 1, the possible values for L will be 0 only, because maximum for L, since L depend on n, is n minus 1 kan. So 1 minus 1 is 0 lah. Okay, so ada 0 je. So when L is equal to 0, okay, the possible value for M will only be 0. Okay, and your S can be plus half or minus half. So in this case, dia letak minus half. So itu adalah possible. So that is allowed. Okay, so this set of quantum number is allowed. Alright. So next, B. Contoh So when n is equals to 2. Okay, when n is equals to 2, your L can be what value? L can be 0 and 1. Can it be 2? No, it cannot be 2, okay? Because maximum is n minus 1. 2 minus 1 is 1 only. So, tak boleh ada 2. So, your L can be L equals to 0 and you can be L equals to 1. So, in this case, dia tulis L equals to 0. So, this is allowed. So, when L is equals to 0, okay, the possible value for M pula apa? The possible value for M will be 0, because this is S orbital. Okay. So, boleh tak M equals to 1 bila L equals to 0? Tak boleh, okay? This is not allowed. Okay, S orbital ada satu je orientation, M equals to 0. So that means that, okay, when L equals to 0, the possible value of M equals to the possible value of M is equal to 0 only, and S ni betul tak? S can only be plus half or minus half. So this quantum number, this set of quantum number is not allowed. Okay. So tadi ayat yang saya cakap tu, that is the ayat for your explanation lah. You have to say not allowed. Why? Not allowed because blah 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 blah. Okay. So yang lain nak buat, try buat sendiri, and we will discuss and this exercise, do it yourself. Alright, so that's part 1 for 2